So example 6, we're looking at solving a trigonometric equation. Find all solutions of 1 plus cosine squared of x equals 2 cosine squared of x over 2. And we're looking at the interval between 0 and 2 pi. So we see that we have a half angle here, and it's squared. So let's rewrite this. We have 1 plus cosine squared of x equals 2 times plus or minus the square root of 1 plus cosine x over 2, and that is all squared. So I just use the half angle of cosine here to plug it in, and then we square it. So now we can simplify. So if we square this side, we're going to get 1 plus cosine squared of x equals 2 times 1 plus cosine x over 2. And then notice the 2 will cancel out as well. So this simplifies all the way to 1 plus cosine squared of x equals 1 plus cosine of x. So let's set it equal to 0, so move everything to one side. So the ones cancel, we get cosine squared of x minus cosine of x equals 0. We can factor out a cosine of x, so this is cosine of x minus 1 equals 0. Using the zero product property, we have cosine of x equals 0, cosine of x equals 1, and so we see when is that true. So cosine is 0 here, and cosine equals 1 over here. So we know that's at 0, this is at pi over 2 and 3 pi over 2. Now we're looking just at the interval of 0 to 2 pi, so 2 pi is not included, so we don't have to list 2 pi. So we're going to say x equals pi over 2, 3 pi over 2, and of course 0. So try this example. Find all solutions of cosine squared of x equals sine squared of x over 2 in the interval of 0 to 2 pi. Okay, if you try this out, plugging in the half angle formula, so you use square root of 1 minus cosine of x over 2, you square it so that gets rid of the square root. Then you multiply both sides by 2, set it equal to 0. So you find when is cosine of x equal a half and cosine of x equals negative 1. And then you see that's true when x equals pi over 3, pi, and 5 pi over 3. Next, we're going to take a look at sum to product formulas. So we notice we're adding or subtracting, and then so this is the formula that we use. So if we're adding two sines together, then you use this formula. If you're adding cosines together, you're using this formula, and so forth. So find the exact value of cosine of 195 degrees plus cosine of 105 degrees. So we're looking at cosine plus cosine. So we're looking at the formula cosine of u plus cosine of v equals 2 cosine of u plus v all over 2 times cosine of u minus v all over 2. So we're just plugging in what we have. So this is 2 cosine of u plus v, so that's 195 degrees plus 105 degrees divided by 2, and then times cosine of 195 degrees minus 105 degrees over 2. Then we simplify, so we get 2 cosine 195 plus 105, that's 300 degrees over 2, and then cosine of 195 minus 105 degrees, that is 90 degrees over 2. So this is 2 cosine of 150 degrees times cosine of 45 degrees. And we can actually evaluate that further. So we're finding the exact value. So cosine of 150 degrees, so 150 degrees is there. And then so we know that 30 degrees is our reference angle. So that is 2 times negative root 3 over 2. Cosine of 45 degrees, that's root 2 over 2. So we can cancel out a 2 here. So our final answer will be negative root 6 all over 2. So try this example. Find the exact value of sine of 195 degrees plus sine of 105 degrees. So we tried this out. Use the sine formula, the addition one. So sine of u plus sine of v equals 2 times sine of u plus v over 2 times cosine of u minus v over 2. So 2 sine of 150 degrees times cosine of 45 degrees. Sine of 150 degrees is a positive a half. Cosine of 45 degrees is root 2 over 2. And that's all multiplied by 2. So it simplifies to root 2 over 2. So let's solve this trig equation. We have sine of 5x plus sine of 3x equals 0. So again, we're using our sum to product formulas. So sine plus sine. So we're looking at sine of u plus sine of v, and that's 2 sine of u plus v over 2 times cosine of u minus v over 2. So you plug in what you know, 2 sine of 5x plus 3x all over 2 times cosine of 5x minus 3x over 2. So this becomes 2 sine of 8x over 2, which is 4x. And then times cosine of 5x minus 3x, that's 2x over 2, which is just x, equals 0. So this all equals 0. And then we solve. So using the zero product property, we have 2 sine of 4x equals 0 and cosine of x equals 0. So 2 sine of 4x equals 0. So this is just going to be sine of 4x equals 0. So when does sine equal 0? Sine equals 0 here and here, at 0 and at pi. Now because we have the 4 here, remember how we have to solve for that. So 4x equals 0, or n pi. Let's say n pi. Then to solve, we divide by 4. So x actually equals n pi over 4. Now this doesn't give us an interval in this case, but if you were, then we would have to solve for all of it. So say, for instance, this is between 0 and 2 pi. I know in the review homework it is in there. And so you actually have to solve for all of it from 0 to 2 pi. So if you plug in numbers, you would get x equals 0, pi over 4. And then you plug in 2 pi over 4 is pi over 2. Then you get 3 pi over 4. 4 pi over 4 is just pi. 5 pi over 4. 6 pi over 4 is 3 pi over 2, and then 7 pi over 4. Then you have 8 pi over 4, which is just 2 pi. And then cosine of x equals 0. So when is that true? X equals 0 here and here. So that's at pi over 2 and 3 pi over 2. And that's already included here in this value. So I'm going over this only because, like in the review homework, you actually have to find all of them. And so you just plug in numbers and make sure that it is within that interval. Now, for instance, in the book, the answer is just x equals n pi over 4. The reason why we listed it here, another reason, is that we already included the 3 pi over 2 and also the pi over 2. So that's another reason why we listed it. Okay, so go ahead and try this last example. Sine of 4x minus sine of 2x equals 0. All right, if you tried this out, you should have gotten 2 sine of 3x equals 0 and sine of x equals 0. So cosine of 3x equals 0 at pi over 2 and 3 pi over 2. Then remember how to change that, but the period is changed. So that is x equals pi over 6 plus 2n pi over 3. Then it's x equals pi over 2 plus 2n pi over 3. And then for sine of x equals 0, that is at x equals n pi.